This video explains how to convert decimal numbers to binary numbers. The first step is to choose your decimal number. So for example, let's choose the number 46. So we write the number 46 on our page, and then the second step is to write 8 spaces. This is because when using binary, usually all digital programming, digital circuits deal with bytes of information. And a byte is 8 bits. Each digit is a bit. So we're going to write 8 blanks to represent 1 byte. So here are our 8 spaces representing our byte, each digit representing a bit. Now starting from the right side, underneath that blank we're going to write a power of 2. We're going to just increase powers of 2 as we go from right to left. So we're going to write 1, then 2, 4, 8, 16, 32, 64, and 128. Now this is because in binary, binaries are based on a base 2 number system. So 2 to the 0 power is 1, 2 to the first power is 2, 2 to the second power is 4, 2 to the third is 8, and so on until you get all the way to 2 to the 7th. 2 to the 7th power being 128. But if you just memorize 1, 2, 4, 8, 16, 32, 64, 128, that'll be sufficient. You don't need to write 2 to the 0 and 2 to the 1. Just put that up there to remind us that yes, we are working in a base 2 number system. The next thing to do in converting our decimal number to binary is starting at the leftmost space. If our decimal number is divisible by that number, that power of 2 number, then we put a 1 in that space. But 128 will not go into 46, so we have to put a 0 in this space. And then we go to the next space, 64. 64 also does not go into 46, so we put a 0. The next space, 32 though. 32 does go into 46, so we can put a 1 there. Then we come over to the left side and subtract 32 from our 46, leaving a remainder of 14. Now our new number we're working with to see if it fits is 14. We look at the next space. 16 does not fit into 14, so we have to put a 0 there. And go to the next space. 8 does fit into 14, so we put an 8 there, subtract 8 from the 14, and get a remainder of 6. 4 goes into 6, so we'll put a 1 there, subtract 4, leaving a remainder of 2. 2 goes into 2, subtract 2 from that, and we get a remainder of 0. 1 does not go into 0, so our last bit is a 0. So our binary number that's equivalent to the decimal number 46 is 00101110. Some people omit the leading zeros. I like to leave those in there to remind me that it's if I have 8 spaces, it's a byte, and if you're working with bytes of information, you'll see those zeros. Now in computer code, oftentimes you'll see some conventional way of indicating that it's a binary number. For example, in C programming, you might see it written as a B for binary, single quotes, then the number, and that indicates that it's a binary number. So I would say it's a good habit to get into to put that B with your binary number surrounded by single quotes, as that's a convention that's used all the time. Let's try another example just to make sure you understand. Let's do a little bit larger number this time. We'll try the number 147. Again, we're going to draw 8 spaces. Again, start from the right and count up in powers of 2. Then we look at our first digit and say yes, 128 will go into 147. So we'll put a 1 there, subtract the 128, leaving a remainder of 19. 64 will not go into 19, 32 will not go into 19, 16 does go into 19, so we'll subtract that, giving a remainder of 3. So 8 does not go into it, 4 does not go into 3, 2 does go into 3, leaving a remainder of 1, and 1 will go into 1. And we've finished our binary number. So we'll write that as, and there's our final binary number. Okay, hopefully this helps you understand how to convert decimal to binary numbers. Part 2 will explain how to go in the reverse, how to take a binary number and convert it to decimal.